Alright, I'm going to quickly talk about direct variation for y'all and what you're doing in the book. Okay, so the first few problems are asking you, can you tell if something is a direct variation? Basically, again, you're looking for, say, y equals k times x, which basically is saying that you're just looking for some number in front of the x but no numbers after the x. So like this equation right here is a yes. It is in the form of y equals k times x. So this is a direct variation. But this one, because of this plus 3, is a no. It's not a direct variation. When you look at it something like this, and this again is referred to as standard form, you can't, if you have a number here, any number other than 0, it's a no. But if you have a 0, it's a yes. Because you could simply move this 2x over here and say 4y is equal to negative 2x, divide by 4, and you've got y is equal to negative 1/2 x. Okay, so you have to be able to look at those and be able to tell if they're a direct variation. Now what happens when you're looking at a table? When you're looking at a table, you're saying, okay, well, again, you need to take y divided by x and make sure they're all the same. So like here I have 7 over 5, 14 over 10, 28 over 20, and then 35 over 25. Okay? When you divide all those on your calculator, you should get an answer of 7 over 5. So yes, this is a direct variation, and actually the equation would have been y is equal to 7 over 5x, because that number right there is the number that goes in front of the x. On the next one, I've got 2 over negative 8, 4 over negative 16, 6 over negative 24, and 8 over negative 32. Okay, divide all those on the calculator and you would get negative 1/4. So this is a yes also. And the equation would have been negative 1 over 4x. Okay, on this one, when you do 5 divided by 1, 9 divided by 2, 13 divided by 3, 21 divided by 5, the answer is no. You don't get the same answer for all of those. If you were to do the method of like the change in the y over the change in the x, you will get a slope. But the problem is this equation here actually comes out to y is equal to 4x plus 1. So you see what I'm doing there is I'm telling you that I can give you a linear equation, and if you follow a certain rule, you'll get a different answer. That won't necessarily be a direct variation. So you have to make sure you understand which question I'm asking for, because I could have asked what's the function, what's the equation of the function, and that would have been y equals 4x plus 1. But I was asking, is it a direct variation? Okay, and then finally, you can find a direct variation just given any point. Like here, again, keep in mind we're doing the y divided by x. 10 divided by 5 is equal to 2. So that means this is y is equal to 2x. Negative 4 divided by 8 is equal to negative 1/2. So that means this equation, direct variation equation, is negative 1/2 x. 3 divided by 21 is equal to 1/7. So this equation is y is equal to 1 over 7x. Negative 15 divided by 3 is equal to negative 5. So y is equal to negative 5x. It's very important to make sure you stick to the whole y over x bit to come up with the equation. That should pretty much do it for what you're going to be looking at as far as the problems are concerned in the book. But if you do have any questions, feel free to ask Mr. Valverde or send me some questions to Edmodo. Thank you very much.